Good morning. So today we're going to be tackling one last little detail about 1.3, and that's the number of solutions. Basically, I call this the lesson of what happens if. What happens if, well, let's see what the if is. All right, so let's just go through the steps here. We're going to solve this problem here. Solve 3 minus 4x equals negative 7 minus 4x. So I follow the steps, draw the river. I eliminate parentheses, there aren't any. I add like terms, I look this way, I look this way, there are no like terms. So I'm not worried about that. So I've got that, I've got that, I've got that. So now I'm going to go ahead and move variables to one side. Variables to one side. So I don't know, I'll just take this one and move it that way. Okay, so I'm going to plus 4x, so that cancels. That's what we're supposed to do. So plus 4x, and I realize something as I'm doing this. This is that what happens if there's 0x. That means that it cancels too. Now what? Well, this is one of the special cases. There are times when we get in this scenario. So what we need to do is examine what's left. So we bring 3 down, and it's equals, and we bring negative 7 down, and we go, oh, 3 doesn't equal negative 7. 3 can never equal negative 7. So what that means then, okay, so let's talk about the scenario here. First of all, the x canceled. So that means that when we got the x's to one side, they canceled out, so there were no more x's at all. And then the remaining statement was false. 3 does not equal negative 7. So what that tells us is that there is no value for x, nothing we can put in for x to ever make this true. So we call this no solution. And so there's going to be some times when we're doing these problems and we get these what if scenarios. What if all the x's cancel on both sides? We did all the steps right, but the x's cancel. Okay, we look at what's left. What if it's false? Well, then it's no solution. And so we get these scenarios. So today we're talking about 2 new scenarios, and then we'll kind of summarize it at the end with all the different scenarios that we could possibly have. Okay, so we get this one. So we draw the river, and we do parentheses. So that means that you're going to have to be able to do 4 over 1 times 3 over 2. So those reduce. 2 times 3 is 6. 1 times 1 is 1. So basically, all right, so we get 6x plus 4 equals 6x plus 4. And you might already notice something here. When we've gone through the river and the eliminate and the add like terms, we ended up with the same thing on both sides. But let's just follow this through because let's see what happens when that happens. So just for the sake of, I'll just go this way. We realize that we go negative 6x. Oh, yeah, that cancels. That was the whole point. So we have to do negative 6x on this side. And we realize, oh, that canceled too. Okay, so our x's are gone. So again, x canceled. So x is canceled, but we have to look at what's left. Okay, that's the next step. So 4 equals 4. Oh, that's a true statement. That's always going to be true. 4 is always going to equal to 4. So that gives us a different scenario. It's true, so that means it doesn't matter what we put in for x. We could put in 1,000,000. We could put in negative 0.000128. We could put in 0. And whatever we put in for x, it's always going to be true. Okay, so the x is canceled. The statement left behind was true because the constant's 4 equals 4. And so then we call that type of solution infinitely many solutions because there is no number to the solutions, no limit to the number of solutions that could possibly, any rational number could fit in there. Any real number could fit in there. Every number can fit in there. So that means there's infinitely many solutions. Okay, so we had two scenarios there. What happens if the x canceled in both situations? Okay, so what happens if the x cancels? Well, if what's left behind, the constants left behind, is false, then it's no solution. If what's left behind, in this case, constants are left behind, and it's true, it's infinitely many solutions. Okay, so we add that then to the scenario, like when x doesn't cancel. Okay, so I'm going to take one of these problems from down here. Let's see if I've got one here. No, I don't know. These all look kind of scary. Okay, so I'm going to take this one here. Okay, and we will talk about why that is different here. We'll put that right here. And how can I just even look at that and go, oh, yeah, that one's going to work. You know, like how can I just look at it and know that? That is a good question. All right, so here's a scenario, and it's going to be something that's similar to what you're going to have for your homework today. All right, so I do draw my river. I add my like terms. 11j plus 4 equals 10j plus negative 3. All right, immediately, right now, I know that when I'm looking at this, I have 11j and I have 10j. Okay, they're not going to cancel. When you look at these up here, when I got to that step, I had negative 4x and negative 4x. I had the same number of x's on each side. When I got to the step here at 6x and 6x, I had the same number of x's on each side. When I look at this one, I don't. Let me just show you this. So I go over here. So I go minus 10j. Cancels. That's what we want it to do. Minus 10j. I end up with 1j plus 4 equals negative 3. So the x didn't cancel. So here's our scenario. X doesn't cancel. You know what? We're going to have one solution. This describes every single equation you have solved up until now. Exactly one solution. J equals something. In this case, negative 7. X equals 3. Y equals negative 2. We always had one solution. If I follow this out, negative 4, so j equals negative 7. So it's one solution. X does cancel. That was these two scenarios up here. Okay, X does cancel. If it's true, it's infinitely many solutions. If the what's left behind is false, then it's no solutions. And those are the types of solutions. That's how we identify the solutions. So what you're doing for the homework today, as you're going through these, is you're having to determine if you have one solution, infinitely many solutions, or no solutions. So we take a look here. I'm going to do this problem here. I'm going to add these, draw the river, do parentheses, 20r minus 5. Add like terms, 20r minus 5. Oh, I subtract 20r, my x's cancel. So x canceled. So I look at what's left. Negative 5 equals negative 5. It's true. So when I go back up here, x cancels, true. It's going to be infinitely many solutions. So my answer, infinitely many. And I guess, and get more math, they just infinite solutions. So we'll just make it easier because then you don't have to write all that much. Infinite solutions. Circle that statement, and you're done. Okay, next problem. Let's look and see. Okay, so I distribute. So draw the river, distribute. 20x, negative times negative is positive at 20x, plus negative times negative is positive 5. Okay, done on that side. So add like terms. That's going to be 20x, and that's going to be positive 5. Oh, now you should kind of start seeing a pattern. If I subtract 20x and I subtract 20x, those are going to cancel, and what's left behind is So x is canceled. And it was true because 5 equals 5. And I'm looking at this right here. Okay, so I know it's going to be A, infinite solutions. All right, let's look at this next one. So I've got 106 equals. Wow, that's a lot. Okay, so I'm gonna bring it to the side so I have more. Negative times negative is positive 40 plus negative times negative is positive 24x minus 54x plus 31x plus 5. So let's see, 24 plus 31 is, make sure I did that right. Okay, is 5, 5. So I've got, I'm adding like terms here. So, and then I've got 40 and 5. So I'm going to have 45 plus, and then I did my 24 and 31 right there. So 55x minus 54x, can't forget about that, equals 106. I already kind of know which direction this is going. So 106 equals, the question we have to ask, do the x's cancel? And the answer is no, because there's not even x's on the other side. We just combined all the x's and it became 1. So the x's did not cancel. So x doesn't cancel right here, one solution. So x doesn't cancel, so it's going to be one solution. Do I have to find the solution? No. I could. I only have one more step to do, so I could, but no, I'm not going to do that. All right, last one, and then we'll call it good. So, all right, negative 4 times negative 2 is positive 8x. Negative 4 times 97. 4 times 7 is 28. Carry the 2, 36, 38. So positive 388 minus 14x equals, do this, negative 6x plus 2. Draw the ruler. Okay, add these like terms. Oh, that's going to be negative 6x plus 388 equals negative 6x plus 2. I was worried about doing the math wrong on that 388, but I'm looking and seeing that once I do this step, I'm going to move this over here. So once I do that, that cancels. Plus 6x, that cancels 2. So I know it's going to be, I know it's not one solution because the x is canceled. And I look at what's left behind, and I've got 388 and plus 2, and those will never be the same, so we have no solution. Okay, so that's 4 problems and plus the notes. So hopefully that's enough for you to be able to kind of reconstruct, since you weren't in class the other day, or maybe you needed some extra help. So yeah, give it a try. There is a lesson attached that you need to complete on a separate sheet of paper and turn in. It looks a lot like this. So that's what you'll do. It's like 10 problems. Okay, you show all your work, take a picture of it, attach it to the assignment before you turn it in. All right, thank you.